All right, so hello, and thank you for coming to my talk about dinosaurs and clouds and other wonderful things. So, about myself, my name is Paul. I live and work in Amsterdam, which is where I'm from originally as well, and I'm a developer advocate at Stripe. If you are unfamiliar who Stripe are, we are a payments infrastructure company. Our bread and butter is doing payment processing, but we're really an API company at heart, and we process a terrifying amount of API requests every single day. And one thing we're really obsessed about is developer experience as well, which is kind of what this talk is going to be about. So I'm going to talk a little bit about the problem that we found, that we had. I'll talk a bit about the fix, and I'm going to end with some big takeaways and hopefully some call to actions about what can be done next. Super quick primer though, just so everyone in the room knows what I'm talking about. Hopefully everyone's aware of Node, but if you're not, it is a JavaScript runtime environment. Deno is a reimagination of Node by the original creator of Node, Ryan Dahl. This is his interpretation of what Node would look like if he could gone back and fix his mistakes. And Cloudflare Workers is a serverless environment built by Cloudflare. Shout out to those guys. And Stripe Node, if you're not familiar, is a client library SDK that we at Stripe have built and maintained. It gets a lot of traffic, just under 1 million downloads a week. We actively maintain it. We've had over 300 releases of it. We spent a lot of time working on this. So, like most good engineering problems, this started with a GitHub issue. Just simple thing, someone asking, hey, can we use Stripe Node outside of Node.js? Like, can we use it in Cloudflare Workers or Deno? This turned out to be the most upvoted issue we've ever seen in our repo. So we felt like we should probably take a look at this. But first, let's look like why would you want Cloudflare Workers for Stripe and Deno as well. So I stole this image directly from Cloudflare. Thank you, Cloudflare, if you're in the room. But Cloudflare Workers is the forefront of edge computing with zero. This is what this graphic actually is like a zero cool starts. It makes perfect sense to want to have the low latency of edge computing. So it also makes perfect sense to have this in your payment stack as well. And then Deno, there's a lot of reasons why you'd want to use Deno over Node these days. There's a bunch of reasons up here on screen. The one that we are the most, at Stripe, are the most excited about is this last point, which is that it's secure by default, where you actually load your packages in via direct URL rather than using a package manager. And as everyone has probably known in this room, has seen the security issues, supply chain issues with Node in general. From our point of view, we love security because we're a payments company. You have to be involved with this stuff. So we like that it's secure by default. But one interesting thing that we want to kind of point out was that if you look at this graph here, the top here is the amount of contributions to the Node.js GitHub repo over the last year, and the bottom is Deno. Now, the top actually has more at Node, but you can see they're both very active projects. However, the interesting thing is that it's really difficult to determine actual usage, but we know for a fact that just looking at things like Stack Overflow, the amount of questions, is that there isn't really that much of an uptick in usage for Deno compared to Node. And I think a lot of why that is because lots of big companies that have these large, or if anyone has a large open source library, has not made those libraries available for Deno, including Stripe up until very recently. And the really point here is that we should really meet developers wherever they are. So people who, if he wants to build a Stripe integration, wants to accept payments for their startup or whatever, they should be able to do that in Cloudflare Workers. They should be able to do that in Node or any other JavaScript runtime environment. They should have the choice, really. So before we kind of committed to look into this, we decided to figure out why exactly it is that Stripe Node does not work in Cloudflare Workers and Deno. And it came down to these 4 things. So first up is Fetch API, which Cloudflare Workers and Deno support out of the box, but Node did not. Little asterisk next to that because now Node does, but only in the very latest version of Node 18. Experimental, exactly. I think it's only just been released like in a stable release, but for most people, if you want to use Fetch in Node, you might want to wait till like an LTS version before it actually comes out. Cryptography here, I was very clear to describe cryptography and not crypto because I don't want anyone to get confused. But essentially Node uses the Node crypto library and Cloudflare Workers use the Web Crypto API, which we'll get to a little bit later, but turns out there are some very subtle but important differences between the two. Path events, this is some core Node libraries that Node has and Deno has, but Cloudflare Workers does not, because why would they? Because it's a serverless environment. and a lovely tricky one about CommonJS, which we'll get to a little bit later. So the very obvious kind of solution would be like, hey, well, if we want to support Cloudflare Workers and Dinos, let's just fork the library twice, have a Cloudflare Workers version and a Dino version, and just hack around and make it work there. That's probably the easiest way to do things, but it's also long-term the hardest to actually support. Because instead of maintaining one library, you're now maintaining 3, and potentially even more in the future if inevitably someone forks either Node or Dino again, and we have another runtime environment to take care of. So we really wanted to go for a single repo that covers all use cases. And the question that we had in our mind was, okay, so how hard can this really be, right? It shouldn't be that difficult to just a couple lines of code, make it work everywhere. Well, to answer that question, we can look at the actual timeline. So in September 2020, the GitHub issue was filed. Embarrassingly later, in May 2021, we actually started working on it. In November of that year, so 6 months later, we launched Cloudflare Worker support, and then a month after that, Dino support landed. So 6 months of time is a lot in engineering, especially when you thought like, oh, this shouldn't be too difficult. So 6 times is a lot. So to answer the question, how can it be, is like, So that was the problem that we had to solve. Now we're going to start looking at what we did to actually fix it. First up, it was very tempting to just say, okay, what we'll just do is some environmental detection. So if I'm running a piece of code in JavaScript, I should be able to tell where I'm running it, right? I should be able to know if I'm in a Cloudflare Worker, if I'm in a Node environment, or if I'm in Dino. And we thought about this for a while, and we came to the conclusion that actually that way lies madness. Because if you try to do some sort of detection, then you have 2 things to think about. You have to make sure that your detectors work forevermore, and you're on the hook to make sure they work. And if any new runtimes, evolve and get popular in the community, you got to make sure that you build new detectors for those as well. So we kind of decided that on an approach of more, don't try to be too clever, which is going to be another big theme of this talk, of stop trying to be too clever. So in terms of environment detection, this little piece of code here is actually all we do in the library. All this does is basically check to see if you have a process global object, which Cloudflare Workers do not have. And if it doesn't, we turn back an empty object. Otherwise, we return the Lang version and the platform, which we use for some telemetry. So next, this was the big one, the big hurdle was the HTTP clients. So Node, as I spoke about earlier, doesn't have the fetch API. Oh, well, it does in version 18 now. Whereas Cloudflare Workers and Dino only have the fetch API. Node uses the old HTTP and HTTPS, which under the hood do the same thing. They're just making API requests. However, the fetch API, I think everyone kind of sort of agrees on is like a more developer-friendly way of using things. So it's not surprising that Cloudflare Workers and Dino opted to not implement the old way of doing things and just went for the new. Now you might look at this and say, oh, well, simple solution. All you need to do is just use fetch in Node, right? Well, there is a Node fetch library that you can use, and I think a lot of people do use, but Node fetch has a minimum requirement Node version of 12, whereas we support the minimum version of 8. So we couldn't do that. We had to think of a solution where we could basically decide whether to use HTTP or fetch at the same time in the same repo. And what that ended up looking like is, again, we're trying to not be too clever here. We're trying to give as much choice as possible to the end user. So we built an HTTP base class, and we let you choose what flavor you want to use. So at the very top here, I have an example of initializing the Stripe library in Cloudflare Workers. We have this helper function, stripe.createFetch HTTP client, and that just creates the client for you. You pass it in there, and it just works. Same for Dino. Looks very similar. And at the bottom, we have Node, which is the simplest of all, because we actually default to the old HTTP library because that is most of our users we found use just regular Node and aren't using Cloudflare Workers or Dino yet, but hopefully that'll change. And we really felt that simplicity really means versatility in this respect. Like, you shouldn't try to be too clever and try to guess what the user really wants to do. You should instead give them the tools to do whatever they want. So as an example, this is just regular Node. And here, if for some reason you really want to use Node fetch, now you can. You can just pass this into the library, and it uses fetch instead of the HTTP library. Whereas before, you were locked into one thing. Now you have the choice, which is really nice. So speaking of which, I mentioned earlier that HTTP was kind of the hard part, and this is because of really fun bugs that we found along the way. There's one in particular that I want to highlight just to kind of show how difficult it can be to get this stuff right. So if you're familiar with the content length header, The top bullet here is actually, I took this directly from MDN. It indicates the size of the message body in bytes sent to the recipient. So the idea is that when you send this, you let the server know exactly how big the payload is going to be. Now, this header, content length, doesn't make sense for HTTP verbs where no body is expected. So like a delete or a get should most of the time not have a body at all. Get can be a little bit weird where sometimes you can do a post body, but you shouldn't really. However, if you have a request with no body whatsoever, so no payload, and you still pass content length, even if it's content length 0, technically that shouldn't work. Now, we rather naively were still passing this in our old Node implementation because Node, like a lot of JavaScript, lets you get away with murder. However, Cloudflare did implement the spec correctly. So when we passed something like this to the bottom, it just errored. So if you try to delete something from your Stripe account, it ended up just deleting the request itself, which is a huge problem. And this was like a funny in retrospect, but it's this kind of like edge case stuff that you have to test for, which can be really hard to do in an HTTP library because there's a lot of little edge cases like this that pop up out of nowhere. So part of the reason why this took as long as it did, the 6 months, is just because we had to make sure that everything worked as expected and there was no regressions. Next up, cryptographic clients. So each of the platforms here do have a version of crypto, but they are implemented in slightly different ways. So Node uses the Node crypto implementation, which is synchronous, whereas Cloudflare Workers and Dino use the Web Crypto API, which is asynchronous. So already there's a bit of a disconnect here. And at the time when we wrote this, Dino did not have any support for HMAC. I won't go into massive details what HMAC is, but you can figure this as a cryptographic way to sign things. We need cryptographic in Stripe Node because we sign webhooks. To make sure that our webhooks came from Stripe and not from some man in the middle, we need to have this cryptographic capability. So again, pretty important to get this right. And we ended up solving this in a similar way to HTTP, where we wanted to give choice back to the user. So this is what it looks like in Cloudflare Workers or in Dino, where we construct this subtle crypto provider. Subtle crypto provider is the name given to the Web Crypto API version of crypto. And again, so it's as simple as creating the crypto provider and using this async function, which is kind of nice because before this function was only available synchronously. You could not do this async, but now you can. Another nice little benefit of having to work through this stuff. Next, path and events. Cloudflare Workers don't have path and events because why would they? It's a serverless function. You shouldn't need to do this stuff. So we had to rely pretty heavily on Browserify here and Webpack. So if you're familiar with Cloudflare Workers, they have a tool called Wrangler, which lets you orchestrate them. And Wrangler is Webpack. So we use here, this is actually just one section of Webpack where we use Browserify to kind of stub out these things that we needed. Now Wrangler 2, which has come out, uses ESBuild rather than Webpack, and we haven't built a template for that yet, but that is coming. So this is really just a case of, it's funny because this is outside the Stripe Node library itself, but there is tooling available to help you stub out this stuff. So if we look at the timeline, we did all this work with crypto, HTTP, stubbing out some stuff. This is about November 2021. And already at this point, we kind of got Cloudflare Workers ready. There was a lot of testing. Shout out to Cloudflare who helped us a lot with this. They helped us test. They helped us build the templates. It was fantastic. But we had one big problem before we could ship Dino. And that is ES modules versus CommonJS. I won't go into a huge amount of details about what the difference is here, but a very naive description is that CommonJS is everybody knows the require syntax at the top, whereas ES module uses the import function. So Dino uses ES modules exclusively. There's no option for CommonJS because ES modules is modern and new and fancy and great, and CommonJS is old. And what's also old is Stripe Node. Stripe Node was originally, the first commit I actually went back and looked was in September 2011. It is a very old library. And at this point, to refactor the whole library to use ES modules rather than CommonJS is a little more than we wanted to bite off right now. So we didn't really know what to do at this point because other than having a large refactor, we kind of felt like, well, this is a dead end here. I'm not sure if we can support Dino. Luckily, our friends at Dino pointed us to a service called esm.sh. This is a CDN hosted on Cloudflare. And what it does is automatically wrap CommonJS modules in ES modules. And because Dino does this loading directly from a URL rather than a package manager, we can do something like this. So you might have already seen this before when I showed a screenshot of how we import stuff in Dino, but this works fantastically, and it was great because we didn't actually have to do anything. It was already solved by esm.sh. So if you're planning on doing this yourself, keep these guys in mind. So now we're at December 2021, and we finally have launched Dino support. Everyone's happy, it's great, etc. And we were quite proud of this work. We were quite happy. But we did have some takeaways we want to think about this. First of all, this really wasn't that easy. 6 months, like I said, and bear in mind this is 6 months at a fairly large engineering company. We had their engineering resources, we had the contacts at Cloudflare, we had the contacts at Dino, and it still took us a long time to do this. And it shouldn't really take this much time, really, because it's all just JavaScript environments. I feel like this should really just work normally. But it was worth it, because now Stripe Node works in any environment which supports fetch. As an example, a couple of weeks ago, we launched a new product called Stripe Apps, which basically lets you extend the Stripe dashboard. And one of the fun quirks of it is that you can actually run Stripe Node in the front end on your browser to make API requests. That's what this code is right here. This is actually running in the browser. But because we fixed up the library to be able to accept any kind of HTTP client, we can now do this, and you can run this from your browser, which I thought was really fun. Second big takeaway is that HTTP testing is not easy. Like the content length bug that I showed earlier, there was more of that kind of stuff. Content length was kind of funny, but there was other really tricky bugs to try and find out. And it's really just tedious trial and error. We had to use, we had to abuse a lot of the testing library Nock. If you're not familiar with it, you should check it out. And just testing it to Cloudflare Workers is difficult as well, because we had a whole testing suite, which we didn't really want to port over to Cloudflare Workers. So we had to really rely heavily on Node Fetch here. And we had to hope that the implementation of Node Fetch was the same as the implementation that Cloudflare Workers had for their version of Fetch. Again, every single platform seems to implement the spec in their own way. They might interpret things differently. Cloudflare might be more strict with the spec, whereas Node decides to let you get away with something. So it's not easy to do this. And people really don't like it when you break things. People don't like it in general when open source stuff breaks. They really don't appreciate it if that open source project powers their payments. So it was really important for us to get this right, because this is a really critical, the HTTP library especially, is a really critical production pathway. And if this breaks, then we'll be in trouble. And the third big takeaway was, like, wouldn't it be great if all of this was standardized? If all of these environments just had the same implementation and just worked together? And this felt very much like a bit of almost like a pipe dream at the time, because we did a lot of work into this to make it work. So imagine our absolute bafflement when just a couple of weeks ago, Winter CG was announced by some very familiar logos you see down here. This group came together and basically is trying to solve this exact problem. They're going to make sure that all these environments can talk to one another and have specs implemented in exactly the same way. So we absolutely love that this has become a thing, that this is a thing. Kind of wish they started this 2 years earlier, but we'll take it now. Because the real big takeaway here is that in order for this ecosystem to grow, and for ecosystems outside of Node to kind of be able to have a chance to be able to succeed, large modules and libraries need to be able to work everywhere, because otherwise they're just going to, if you as a new person want to look and see at your stack, you said you wanted to use Stripe, and Stripe does not work on Dino, you might decide not to use Dino, because you probably don't want to spend too much time building your own implementation of Stripe Node, but for Dino. So we're extremely happy to see that this is like the future. Really hope that some good conversations come out of this. I hope you guys all check this out. The last thing I want to kind of talk about is, some of the tools that we think could really be useful here, things that we really need as part of this whole process. So this kind of ranges from a little bit more something that's easier to do to a little bit more pipe dreamy. What is hopefully a bit more pipe dreamy is like some sort of automatic HTTP to HTTPS to fetch conversion automatically. If you had some sort of tool that scanned your code, saw that you were using these other libraries, and automatically polyfilled and put fetch in there, it would be fantastic. Especially if you have a well-tested conversion tool that can help you with all these little intricacies with different implementations. CommonJS ES modules tool would be great as well. Obviously, esm.sh exists. However, it's a little bit of a hack, and I think that maybe with more complicated libraries, they might not work as well. So if there was an actual reliable way to convert your CommonJS to ES module, some sort of linter that can actually just fix this for you, that would be amazing. And finally, like making HTTP testing easy. Yes, please. Because finding all these different edge cases and having to pore through the specs yourself is not fun. I don't think anyone really wants to do that. And just being able to have some sort of tool or testing suite that can actually check to see if your implementation does match the spec will be amazing. So just to conclude, this is one a bit quicker than I thought it was going to be. Just to conclude, yeah. If you have an open source library and you are thinking about converting to like making sure that it works in Dino in Cloudflare Workers, I highly recommend you do it. It is worth it. It's going to help the ecosystem, and it's going to help everything grow. Thank you very much. Sorry, can you say it again? Do you have numbers for the adoption of the library? Do we have numbers for the adoption? We don't really release numbers of the adoption itself, but we do have an inkling. NPM is public, right? NPM is public, yeah, but NPM is not really, NPM is only, doesn't really, well, Dino doesn't use NPM for starters. But we've seen a steady uptick in use of both Dino and Cloudflare Workers, with Cloudflare Workers being, I think, more up and to the right than Dino is. But I think that's just a function of Dino still being very early on in its life cycle.
Did you ever consider creating alternate packages early on that were like specifically targeting workers? For example, like creating a whole library like Stripe workers or something like this. I'm thinking about the way that we're using the word node now to also mean all of these other runtimes.
Mm-hmm. We did consider it early on, but we did not want to have multiple forks. We didn't want to have to maintain multiple versions of the same thing. We really wanted to have everything contained in one single library. Because I mentioned this earlier, that if you do go down that path, every time a new runtime comes out, then you have to try to support that as well. And then you're not maintaining one library, you're maintaining multiple. And you're trying to keep them in sync as well is very difficult.
The word node now is like...
It's overloaded, yes, for sure. If you have any other questions, I will be outside if you want to chat to me. And otherwise, thank you again very much.